There were a lot of questions about the final problem on our last summative, and some people actually had some pretty great solutions. I'm going to actually borrow from a couple of students who had a really good solution, I thought. But first, I'm going to present the solution that I came up with when I solved this problem. We have a cliff diver, and he's leaping off of a 10-meter cliff, and he hits the water 2 meters from the base of the cliff. And then he also reaches his maximum height when the horizontal distance from the cliff's edge is a half a meter. The path he follows is, of course, parabolic. That's a clue that we're dealing with a quadratic equation here. And we're asked to find the function h of d that relates his height h above the water and the horizontal distance d from the cliff. And it says, there's a hint. Draw and label a diagram with the relevant information. And so that's what I have here. We haven't really talked a lot about drawing diagrams, but look, there's clearly a cliff and some water in this diagram. And so I've drawn the cliff here with the person on it, and then I've drawn this parabolic path that they're going to follow down to the water. And then I drew my axes over this drawing. And I labeled this vertical axis h because it's representing the height, and the horizontal distance d is my horizontal axis. So I'm not using x and y because I've been given variables h and d for this problem, so I'm going to use those. This is a 0.5 right here. That's the maximum point that he reaches, and then when he hits the water, he's 2 meters from the base of the cliff. So again, interpreting what that means is an important part of this problem. And also in my vertical axis, I know that he leaves from 10 meters. So I can take the information that I've been given here and write these two things right away. I know that h of 0 is equal to 10. In other words, the top of the cliff is 10 meters high, and he's 0 meters away from the cliff when he jumps. Also, h of 2 is equal to 0. That's the information that we're given about this point. When he hits the water, his height above the water is 0, and that happens, or when he's 2 meters away, he's 0 meters above the water. So I decided to start off with this formula right here in vertex form. And I don't know what a is. D is my variable. That's like my x, right? H of d. So that's my d right there. I do know that the vertex happens when d is equal to 0.5, so I can put that right here. And then I don't know this constant either, k, which is really how high he gets right here. So I do have these two things, a and k, that I need to find, and it's useful that I have two pieces of information to do it. So I'm going to use the first piece of information, h of 0. I know that that's equal to 10. And so when I plug 0 in for d over here, I just get a negative 0.5. And then I can do a little rearranging here, and I chose to, when I squared negative 0.5, I got 0.25, and I just wrote it like a fraction here. So that gives me one equation. It's actually a linear equation in terms of a and k. Those are the two things I'm looking for. And then my second point that I know is that h of 2 is equal to 0. And so when I plug 2 into my formula up here, I get a 1.5 in the parentheses. And again, I don't know what a and k are, so I do a little bit of simplifying. When you square 1.5, you get, that's 3 halves, so I got 9/4. So I'm just going back to fractions here because it's a little easier to work this problem with fractions, I think. And so I've numbered these two equations, and now I can solve this system, which I do right here. And I did this by by first of all just multiplying the first equation by 4 to get rid of the fraction, and I multiplied my second equation by 4 to get rid of the fraction. And that's nice. I can solve this with elimination pretty simply by subtracting one equation from the other. And I end up coming up with a equal to -5. And that makes sense because I know that a needs to be negative if I'm going to have a downward facing parabola, which I do. And then I can go back and figure out what k is equal to, and it's 11.25. So when I put all that together from my original quadratic in vertex form, I can just substitute a and k right in there, and that's my relationship, and that's it. That's what we're looking for here. And I'll say that the other solution that I thought was really great, I'll kind of do it on this piece of paper, is to notice that this parabola must be symmetric. So there's got to be some root over here, or in other words, there's got to be an x-intercept over here that's the same distance from this point as this point. So if I went from the vertex up 1.5 to get to 2, then if I go from the vertex down 1.5, I'm going to get to -1 meters. Now, of course, he's never going to achieve -1 meter distance from the base of the cliff, but we can use this to construct our parabola. So now I'm just going to start off h of d is equal to my constant a times d plus 1. That's the root that I just found. And then also the other factor is going to be d minus 2. So now I've used the factored form of the quadratic here because I know that I know my two roots, and I've used the symmetry of this parabola to find them. And then it's as simple as acknowledging this information once again. I know that when I plug 0 into this formula, I know that h of 0 is equal to 10. And so that must also equal a times d plus 1 times d minus 2. And but what do we know what d is? It's just 0. These are zeros right here. So let's simplify this. 10 equals a times 1 times -2. So 10 equals -2a, so a equals -5. And then it's as simple as just writing h of d equals -5 times d plus 1 times d minus 2. And that's a fine relationship right there. We could leave it like that. If you prefer to multiply that out into a standard form, you can do that. And of course, if you complete the square, you could eventually get it into this vertex form as well. But I thought that this was just a really great approach for this problem to understand the symmetry of the parabola, and then use that to determine the roots, and then simply use the y-intercept, or in other words, the height of the cliff, to find that scaling factor.